Hello, good afternoon. First time I've ever done anything like this, so hopefully it goes well. There we go. So just a little bit about me. I followed their notes for creating the presentation. So I'm a freelance consultant, who gets dragged into usually when things go wrong or some interesting challenge comes up. So this is basically a presentation about a very recent. I say recent, it covered about 2 years because various projects ran at the same time. A large multinational company that actually we work with Pulsant, so it's quite interesting, that decided to do a spin-off, but it was in amongst of other projects that were going on. They were in the process of moving their data center from Europe to America. It was only supposed to take 9 months. A year and a half later, it was still in transit. During that time, they'd also started an acquisition of another company. So there was 34 sites around the globe that they were acquiring. And then the business decided to take a shift and say, well, put the brakes on. Them 34 sites you just integrated, can you take them back out again? Can you also take this other business division out? And can you do it in 6 months? Because if we do it in 6 months, it's a tax-free spin, and the shareholders don't have to pay any tax. So the 6-month cutoff was a hard limit, had to be done. So yeah, it was a lot of small things needed all to come together. So the first bit was I at the time was working on the acquisition with them and got changed to handle the divestment. Lots of teams are running around thinking, how the hell are we going to do this? 6 months isn't very long. So basically, I initially got brought in as the architect overseeing the whole separation. We worked with the applications team to start understanding what the applications team needed to try and separate this company in a 6-month window. We had to plan how to get some of the systems that had already made their way across the Atlantic back again. And when you've got a SAP system with a 4 terabyte database behind it, it takes a little while to get it back across the wire. And also try and figure out how we were going to do a WAN separation, because not many telcos can drop global WAN links around the world and have them ready on a site within 6 months. You know, some sites land, some sites don't, so you need to plan for contingency. So just to set the scene a little bit of what was going on, the acquisition that they had coming in previously, unfortunately, had conflicting address spaces. So we had a bunch of ASAs in place that was doing subnet level NAT, but with also DNS translation on it as well, so we could coexist mixed IP spaces at the time. And as I mentioned, we also had half the systems that were on the end of an OTV tunnel, routed out of Europe, but sat in a data center in Texas. So we had to try and figure out how we were going to bring all these things back together to put them into one company ready to float them out. So the first bit we were working through is like, okay, let's get some application servers and stuff online. Fortunately, the company had some space in their existing data center in Europe, so we threw a few extra VLANs in and started using their spare capacity to start cloning some of the virtual machines and bringing on some of the infrastructure. So normally when you do a divestment, a company buys you. You've got something you know what you're going to. This was a spin-out. There was nothing. To the point, they didn't even have a company name. So trying to sign contracts with somebody where you're going along, I'd like to sign a contract, what you called? Don't know. They eventually registered the company as Spinco, so it actually got given a British company number under Spinco, and then later renamed the company once they determined what it was going to be called. So they come along and say, right, we need an Active Directory forest. What are we going to call it? So we came up with a very original name, DOM01. And they're now having to live with the pain. So there was literally building an entire company from scratch. You know, Active Directory came up within 24 hours and we started to throw applications and stuff in it. All on a new network that was built in an afternoon in a live data center. So then stage 2 starts coming along. The new data center starts coming online. We use the same data center provider in Europe. New calls started to come on, so we basically stretched and moved the VLAN. So the VLAN started to be routed from the new data center, but the servers were still running in the old data center. We had to get all sorts of exemptions from the provider to technically join together 2 tenants within their same data center. We dropped a set of ASA firewalls in on both sides because we knew at some point there's going to be a transition service agreement in which both companies are going to need a bit of connectivity for a period of time. So all that was in place. Things were generally working okay. Then it came to the WAN component. So as I mentioned, not all the sites were going to get WAN links and stuff in time. And the WAN at the time was managed by AT&T, but had been acquired via various other acquisitions. So nothing on the WAN was standard. And I know the Cisco guy mentioned about automation. That would have been an absolute godsend, because when you've got 60-odd different routers, everyone's got a different config. Trying to figure out what you're going to move where, how you're going to move it was just a nightmare. We also then ran into the problem of, like, okay, we're going to start moving WAN links. We're going to have to do some sort of mutual route redistribution between the companies. Company all ran BGP on the WAN, so BGP was going to be the obvious option to use, but unfortunately, the company had such an old ASA that was running, because it was a multi-context ASA we were reusing, didn't support BGP. So we tried to just put mutual peers between it, and we brought down the network. They weren't happy. So we eventually had to run with EIGRP in the middle. Wasn't pretty. It worked, sort of. So that's basically how we got the network up and running. We then moved on to the next challenge of, how do I get a 4 terabyte system with 40-odd servers that are currently sat in Texas back across to the European data center, and they will give me about 12 hours outage. So basically, we went through a bit of a subnetting game with them. It was a bit of a challenge. So previously, when they moved it, they basically extended the layer 2s across the Atlantic, moved the systems over, and eventually just swapped the routing over. Would have all been perfectly fine, but we weren't bringing everything back. Because we were only taking a small chunk of the business, not all of the servers needed to come back. So what we eventually did is broke and forced them to resubnet the servers into small chunks. So what we had them do is take their 40-odd servers and say, okay, which servers need to move together? So you've got within the ERP landscape, you've got a module for warehouse management. That requires 3 servers. So we'll put them 3 servers on their own little subnet. So we took a few /24s, broke them down into really small subnets, and forced them to place individual landscapes, as you could say, in them individual little subnet pockets. And what we then did is copied them servers, virtual servers, across the network, and then flipped just that individual small chunk of the subnet. And once everything was over, the phase 5 of it, we basically reassembled the /24s. It worked really nicely. In comparison to the OTV method that went previously of having 2 servers that they thought needed to talk to one another, both of them moved across the Atlantic, performance was horrendous. And when, after investigating, we realized the inter-VLAN routing was still done in Europe. So the traffic went US, Europe, and back again. Yeah, it's what happens when you do a data center move and it's not designed, and they use an external consulting company who is adamant they can make the speed of light go faster than the speed of light. But then we ran into the exciting bit where the new WAN actually started to drop in some locations. So at this point, we've got the applications team relatively happy. The cloning servers starting to configure applications. They're all quite happy. We've got a data center online. Everything's more or less working as it's supposed to. We're then at the point of let's start concentrating on the WAN with all the unknown elements of it. Also, we found out during some of the investigation that not all of the sites had out-of-band management for their routers. So some sites and migrating their routers was a little hairy. China and places like that, no out-of-band management, and you need to reconfigure the router. So yeah, it's lots of little challenges. Every day I had something different. As I mentioned, overview of the WAN. So initially we thought just bounce the links over. We bounced one of the first links over and all hell broke loose. What we basically did is turned a site in France into the transit site between the 2 data centers. So instead of having a 40 gigabits per second link, the whole intercompany transfer went down to 2 meg, which caused a few problems. We then realized the reason the problem was is the vendor who ran it didn't put any filters on any of the routers. Slightly my fault. We should have really checked, but I had so many other things going on at the time, it didn't occur to me to actually check the config, and I left AT&T to do their magic of moving the MPLS link. So the first lesson we learned there was make sure you got some BGP route maps and stuff in place, otherwise you create lots of transit sites. So we started putting them filters and stuff in place on all the sites before we bounced their links. We weren't able to move the VPN links at the time because, unfortunately, we were having a few problems with RIPE and the lack of IP version 4 addresses. So we didn't actually have a block of addresses to give to the new company. So we weren't able to migrate any VPNs at that point. Eventually, we managed to free up an old block of addresses from the parent company by moving 1 or 2 little servers off it, freed up a whole /24 block that we then stole off them and assigned to the new company. And we were then eventually starting to be able to move the VPN links and actually get all the sites over in their entirety. Moving some of the sites without out-of-band management got quite interesting because at the point you start reconfiguring the VPN tunnel, you have a tendency of losing the site. So there's various different routes we went. For sites that had an MPLS, we were able to use the MPLS link, force the site over, reconfigure various links, and bounce them back. The most interesting bit, and actually I think it was from one of the UKNOF forums I actually found out about it, was Cisco's tickle scripts. Absolute and utter lifesaver. Reload in 10, throw the tickle script at it, it reconfigures it. If the VPN comes up, great, go in and cancel the reload. If it doesn't, wait for it to reboot, try again. And eventually you'll get the config right, and it'll eventually come up. And so worked an absolute dream in getting them across once we'd fine-tuned it all. It took a few attempts, but we did have a trainee engineer who was helping me on this. He unfortunately made a few mistakes and actually did the reload in 10 and the tickle script on the core. That didn't go down well, but you know, he was a trainee. We'd only had him 6 months out of university, so he was definitely thrown in at the deep end. As part of the migration as well, I know we don't have anybody here from AT&T, do we? That's good. The AT&T had configured the VPN routers. There was no zone-based firewall, no VRFs or anything. It was literally an ACL, and they used a route map for guest wireless to set the next hop. Once we discovered that configuration, we basically ripped it out and followed some of the Cisco best practice of a front door VRF and a zone-based firewall wrapped around it, which, again, took a little bit of time to design and stuff, but it made it a lot more secure and opened up a lot more options in the future once the network links got moved over. We then got to the point of moving into TSA, in which we had to drop mutual redistribution between the companies. So basically we dropped EIGRP and put some NATs in place. So there's some firewall rules there, basically NATing all of one company out of selected addresses on the other side for the TSA window. As far as I'm aware, I think some of that is still in place. It's not a client I'm dealing actively with anymore, but hopefully the point of actually doing that disconnection and then it was 2 completely separate businesses. We had a few interesting issues as we started to do the migration. The WAN was not designed for the amount of data we were having to move across it. And then because of the extremely short spaces of time, we didn't have time to upgrade the WAN links. So some of the things we had to look at doing is what we know as offloading. So basically, you've got a 2 meg WAN link on the site, but you've got a 20 meg internet link. Let's start sending some traffic in different directions and get a little bit creative just to get some of the sites across. The normal route for traffic would be across the MPLS link. And what we wanted to do is start sending some traffic across the VPN link, primarily things like internet traffic and stuff, because if moving your data center to the US, acquiring a business, carving it back out wasn't enough, they decided to throw in the mix an Office 365 migration because they'd signed a contract with Microsoft in which they'd bought back their perpetual licenses with the view that they would have a 60% adoption of Office 365 in the next 3 or 4 years. They have to be completed that migration by December this year. So in amongst all of this, they had to start gearing up for a 365 migration. Otherwise, they would have had about a 3 million bill to buy back their perpetual licenses. So they're migrating to 365 and sending all that traffic across the network at the same time we're trying to do some of these crazy projects. So what we did is something quite creative on the cores and stuff within the data center. I'll pull up the next slide, it should show us, yeah. The different lines are basically explaining the different ways in which the traffic was flowing. What we basically did is applied a route map on the core switches in the data center. saying if the traffic is coming from the SCCM server or the AV servers, set the next hop to be the VPN head-end router. And using prepends and things within BGP, if the tunnel was up, that was the more preferred path back to the site. If the tunnel was down, it would send it across the MPLS router and it would still get to the site. And we advertise them as more specific routes on the VPN router to force the traffic back up the VPN link and not have asymmetric traffic. It worked like a charm. Gave way more capacity for some of the really bulk applications like SCCM and antivirus and stuff, which is you're bouncing every machine from one forest to another, is causing a massive amount of network load. And the next one with the Office 365, we decided to implement something called DIA, Direct Internet Access. So a lot of the sites had these really big internet links that they weren't really utilizing. In the previous company, all internet traffic went to the data center and out through the corporate firewall. As part of this separation, they decided to adopt a web-based proxy. So it was very easy for us to do the direct internet access and say, let's save some bandwidth and actually send it straight out of the router. Because we'd implemented VRFs and zone-based firewall, that again made life a lot easier to be able to do the offloading. Again, a small example, we basically used, there's a Cisco white paper out there on how they recommend to do DIA. Fantastic read. Internet VRF, you create a guest VRF and you got your global table. BGP is bound into your global table. And because you've got different VRFs, you can advertise the default route in the separate VRFs, and it just works really quite nicely. As we explained here, the global table we natted out of the Internet VRF and wrapped within the zone-based firewall to only allow clients to go to the web-based proxy. And inside the internal BGP, we only advertised the global proxy internally. I'm got ourselves a bit. Yeah. So we only advertised the global proxy into the internal BGP, meaning the local site would hit the edge router. It would see that the traffic it's going to is for the web-based proxy, go across the internet router and out through the internet link. In the event of the internet link going down due to IPSLA, it would send it across the MPLS link and go out via the data center. The slides did have a lot more of the technical content in, but it's the first time I've done the presentation, so I wasn't sure how technical to make it. But like I said, there's a Cisco white paper out there which I'd highly recommend reading on the DIA and how to use all the different VRFs within their routers. The only thing to be aware of on the 4Ks, which it's actually got me as well, is there's a performance license. You don't install the performance license, you have very poor performance on the routers. That's really the only issue I ran into with the 4K routers. Any questions? I know it was quite brief and quick. This is when we find he's from AT&T.
No, it's changed from Jessica. Going back to Chris's presentation, did you think about doing this on V6 instead of on V4?
I would have. It would have made life a bit easier, especially on the internet-facing addresses, would have made life a bit easier to put some V6 in there. Unfortunately, a 6-month window to do this carve-up. Their internal systems are all IPv4. AT&T are not the most dynamic company in any way, shape, or form. They pretty much were unable to help in this entire migration. So they had a managed router service for the company's routers. As part of the separation, AT&T couldn't actually gear up the resources in time, so we had to take all of the routers off them, and I had to take over management of all the MPLS routers during transition because AT&T couldn't actually even gear up enough manpower to assist with their own managed router service.
Hi, Neil McRae from BT. See now that you've gone through this process, is there anything in the regular kind of business as usual that you do differently now? Having learned from having to unpick this? We would have definitely verified the config of the routers first, because that caused us a lot of issues. Because of the speed that it was going, we unfortunately made some assumptions that we saw one router, this was going to be the standard config. It wasn't. There must have been about 30 different configs of AT&T's own managed routers. They didn't keep their own configs the same, and that caught us out quite considerably. Definitely getting the good books with your data center provider. So their data center provider
was incredibly helpful. We got some of their senior network guys to work with us. The layer 2 was provided by the data center provider, so we only had to worry about the layer 3 and stuff that sat on top of it. And because we had a really good working relationship with them, it sped the whole process up really quickly from building VLANs and getting the switch ports and stuff changed. We should have dealt with the public IP address bit sooner. That got left until like 2 months till the end of it when they needed to start building a DMZ and stuff, that we then started tackling the public address space. Really should have picked that up a bit sooner, because that did massively delay splitting some of the internet-facing components.
Okay, thank you, Andrew.
Thank you.